So hello dear second year PU Science students of Dodapapa Residential PU Science College. So today we are going to discuss the synopsis of three-dimensional 3D geometry. 3D geometry. So in case of three-dimensional geometry, you have studied already in PUC first year three-dimensional geometry. So but slight extension of that is there in PUC second year. So in case of second year PU three-dimensional geometry, we are going to study these things, and those things are basic things from the point of PUC second year. Just in brief I am explaining. So afterwards in detail PDF form we are going to study and explain. So the first point in this 3D second year 3D is direction cosine cosines and direction ratios. This is one thing you are going to study. So what is the here? If you are having directing angle as alpha, beta, gamma, then if a straight line makes an angle in three-dimensional axis as alpha, beta, gamma, then cosine of these angles, cos alpha, cos beta, cos gamma, these are called direction cosines of line. So this is the thing. With this actually the concept of 3D starts in the second year. After that, direction relationship between direction cosines, direction ratios and direction cosines and direction ratios. So if you are considering A, B, C as DRS means direction cosines, L, M, N represent direction cosines, then there is a relation you can calculate. L is equal to plus or minus square root of A square plus B square plus C square. This is the first relation. L. M is equal to plus or minus B divided by square root of A square plus B square plus C square, and N is equal to plus or minus C divided by square root of A square plus B square plus C square. So this is the relationship between direction cosine and direction of line. Next, one more relation is there, that is very familiar. L square plus M square plus N square is equal to 1. This is also important. And next point is direction cosines of a line joining direction cosines of a line. Just a minute. So next point is direction cosines of line joining 2 points. Direction cosines of line joining 2 points. Line joining the points. P is having coordinate x1, y1, z1, and Q is having coordinate x2, y2, z2. Here direction cosines of line joining 2 points is x2 minus x1 divided by PQ, y2 minus y1 divided by PQ, z2 minus z1 divided by PQ. So where where PQ is equal to square root of x2 minus x1 whole raised to square, y2 minus y1 whole raised to square, plus of z2 minus z1 whole raised to square. Just the next page I am writing. So here value of PQ is equal to square root of x2 minus x1 whole raised to square plus y2 minus y1 whole raised to square plus z2 minus z1 whole raised to square, where the value of PQ in the denominator. Next, fifth point, direction ratios. DRS of line joining 2 points. Direction ratios of line joining 2 points. DRS, direction ratios of line joining 2 points. Once again, x1, y1, z1. Q is having coordinate x2, y2, z2 is x2 minus x1, y2 minus y1, z2 minus z1. So next, these are the very basic things. So we are going to study equation of line passing through a equation. Next point, we are going to study 6th point, equation of a line passing through a point in Cartesian form, in vector and Cartesian form. So in next, whatever the derivation we are deriving, so both relation we are writing vector as well as Cartesian form of the equation of straight line passing through 1 point or 2 point. And next, angle between two lines. So many things are there. Those things are already there in the PDF form that we are going to observe just now. Come to the okay, next here, yes. Now whatever in brief basic things, fundamental things required to study or to know the three-dimensional geometry. Basic things for studying three-dimensional geometry. Basic things for studying three-dimensional geometry. Basic things for studying the three-dimensional geometry I have explained, and each and everything in the descriptive, all the quantities I have given here. In case of this three-dimensional geometry, the first thing, as I have told just now, first is direction to sense of a line. If the diagonal line OP makes an angle alpha, beta, gamma, makes an angle with the positive direction of x-axis, y-axis, z-axis respectively, then cos alpha, cos beta, cos gamma are called direction cosines of a line. They are denoted by L, M and N. Therefore, L is equal to cos alpha, L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. Also, in relation, we can write sum of square of direction cosines of a line is always 1. That is L square plus M square plus N square is equal to 1, or cos square alpha plus cos square beta is equal to 1. Now, next concept well, that is direction ratios of a line. Number proportional to direction cosines of a line are called direction ratios of a line. The number proportional to the direction cosines of a line are called direction ratios of a line. First point here, what are these ABCs and what are these L and M may arise. Here ABC are direction ratios of a line and L and M are direction cosines of a line. Then LA is equal to M is equal to NC. If AB, C are direction ratios of a line, then its direction cosines L is equal to plus or minus A divided by square root of A square plus B square plus C square. M is equal to plus or minus B divided by square root of A square plus B square plus C square, and N is equal to plus or minus C divided by square root of A square plus B square plus C square. Next, to direction ratios of a line joining the points P, Q, passing through the points P is having coordinate x1, y1, z1, and Q is having coordinate x2, y2, z2. Given by x2 minus x1, y2 minus y1, and z2 minus z1, and direction cosines are x2 minus x1 by pq, y2 minus y1 divided by pq, z2 minus z1 divided by pq. Note that direction ratios of two parallel lines are proportional. Direction ratios of a line are not unique. Next concept, this one, straight line. So a straight line is a curve such that all the points on the line segment joining in 2 points of it lies on it. So straight line generally in case of geometry also you know. So here also same straight line we are going to study in the 3-dimensional geometry. Next important thing is equation of a straight line passing through one point. This is the thing, equation of a straight line passing through a given point and parallel to given B. So in general, in the equation of straight line passing through one point for analytical geometry is y minus y1 is equal to m into x minus of x1, where m is the slope of the straight line. So that we are studying in case of 3D, equation of a line through a given point and parallel to a given vector B is given by vector R is equal to one thing here, vector R is equal to vector A plus lambda vector B. So equation of a straight line passing through a given point parallel to a given vector B. This is the vector form. This is the vector form of the equation of straight line, where A is the position vector of a point through which the line passing vector B is a vector parallel to a given line. So this is a vector form. So similarly we can write Cartesian form of the equation of straight line passing through one point, that is x minus x1 by A is equal to y minus y1 divided by B is equal to z minus z1 divided by. So this is the equation of straight line in the Cartesian form. That line is passing through a one point having coordinate, if you want, x1, y1, z1, where x1, y1, z1 is a point through which the line passing through, and A, B, C are the direction ratios of the line. So the relation can also be, now this is if L, M and N are the direction cosines of the line, then equation of the line is x minus x1 by L is equal to y minus y1 divided by m is equal to z minus z1 divided by n. Remember the point, before we use the direction ratios of a line, first we have to ensure that coefficient of x, y and z are unity with the positive sign. In other words, the coefficient of x must be 1. That is the standard form. This coefficient of x must be 1. If it is not 1, you make it as 1. So now next, similarly, instead of passing through one point, it is possible that it may pass through 2 points. At that time, what is the equation of straight line passing through the 2 point? So vector R is equal to vector A plus lambda times of vector B minus vector A. So this is the equation of straight line passing through 2 points in the vector form. Only this minus B A minus of A is extra for passing through a point. Next, similarly, in case of Cartesian form, x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 by z2 minus z1. Where x1 comma y1 comma z1 x2 comma y2 comma z2 are the points through which line is passing. Next point, angle between two lines. So in case of 2D also we have studied angle between two lines here, but slight different vector form. Angle between the two lines, angle between the lines, first line is vector R is equal to A vector A1 plus lambda vector B1. Vector R is equal to vector A2 plus mu vector B2. These are the two lines. The angle between these two we want to calculate. That is the formula for this is the cos theta is equal to vector B1 dot vector B2 divided by modulus of magnitude of B1 dot into magnitude of B2. So this is the vector form. Similarly, the Cartesian form, if theta is the angle between the lines x minus x1 divided by a1 is equal to y minus y1 divided by b1 is equal to z minus z1 divided by c1, and the next line x minus x2 divided by a2 is equal to y minus y2 divided by b2 is equal to z minus z2 divided by c2. Then cos theta is equal to a1 into a2 plus b1 into b2 plus c1 into c2 whole divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus of c2 square. So instead of cos theta, this can also be transformed into written as sin theta as the formula square root of a1 b2 minus a2 b1 whole raised to square plus of b1 c2 minus b2 c1 whole raised to square plus c1 a2 minus c2 a1 whole raised to square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus of c2 square. So next, also angle theta between two lines which direction cosines L1 comma M1 comma M1 N1 and L2 comma N2 comma N2 is given by cos theta is equal to L1 N2 plus M1 into M2 plus M1 into N2 or sin theta is equal to this is the relation. So next, here there are two particular cases we can consider. One is the two straight line may be intersected. You may get acute angle, obtuse angle, or particularly those two straight lines may be perpendicular, may be parallel. So straightforward you can decide whether the given lines are perpendicular or parallel. As we are deciding in case of analytical geometry, the product of slopes of two straight lines equal to -1, then those two straight lines are perpendicular. In case of two dimensional geometry, if slopes are equal, then the two straight lines are parallel. So this thing we are deciding in case of the two-dimensional geometry. In case of three-dimensional geometry, here two lines are said to be perpendicular in the vector form b1 dot vector b1 dot vector b2 is equal to 0. In Cartesian form, a1 into a2 plus b1 into b2 is plus of c1 c2 is equal to 0, or L1 into L2 plus M1 into M2 plus L1 into N2 is equal to 0, if that is in the direction cosine form. Condition that two lines are condition. So this is the condition. Keep in your mind. This is for perpendicular. This is for parallel. So that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. One form L1 into L2 plus M1 into M2 plus L1 into M2 is equal to 0. Another form direction cosine by using. So next, instead of perpendicular, it is possible that those two straight lines may be parallel in the vector form. That is A1 divided by A2 is equal to B1 divided by B2 is equal to C1 divided by C2. So next is, or we can write L2 divided by L1 is equal to M1 divided by M2 is equal to N1 divided by N2. This is the direction for sine. So next formula, shortest distance between two lines. So two non-parallel and non-intersecting straight lines are called skew lines. So here, in case of shortest distance between the two straight lines, we are studying the skew lines one concept. Skew lines. What are the skew lines? Here, two non-parallel and non-intersecting straight lines are called skew lines. For skew lines, the line of the shortest distance will be perpendicular to both lines. Here, next, the shortest distance between the two lines. One line is this line is this one. Another line is this. This vector R is equal to, don't get confusion, vector A1 plus of lambda times of vector B1. Next another line is vector R is equal to A2 plus of lambda times of vector B2. Then shortest distance formula is modulus of cross product of B1 and B2. That is that A2 vector A2 minus A1 all divided by magnitude of B1 cross B2, where A2 A1 are position vectors of the point which line is passing, and B1 B2 are the vectors in the direction of the line. Next, Cartesian form of the line. Two lines, those two lines we are going to consider in the Cartesian form. Then x minus x1 divided by a1 is equal to y minus y1 divided by b1 is equal to z minus z1 divided by c1. X minus x2 divided by a2 is equal to y minus y2 divided by b2 is equal to z minus z2 divided by c2. Directly you remember this formula for finding shortest distance. D is equal to modulus of x2 minus x1 a1 a2 y2 minus y. Determinant is modulus of determinant of x2 minus x1 divided by x2 minus x1 a1 a2 y2 minus y1 b1 b2 z2 minus z1 c1 c2, and under root of b1 c2 minus b2 c1 whole raised to square plus c1 a2 minus c2 a1 whole raised to square plus of a1 b2 minus a2 b1 whole raised to square. Next, distance between two parallel lines. If two lines A1 and A2 are parallel, then they are coplanar. Then the lines vector R is equal to vector A1 plus lambda vector B2, and vector R is equal to vector A2 plus mu B2. Then the distance between parallel lines formula is given by modulus of vector B cross product of vector B and vector A2 minus A1 divided by vector B. If two lines are parallel, then both have same direction ratios. So next, distance between two points may be studied in the PUC. First year 3D, distance between 2 point formula is the distance between 2 points. P is having coordinate x1, y1, z1. Q is having coordinate x2, y2, z2 is given by under root of x2 minus x1 whole raised to square, y2 minus y1 whole raised to square plus of z2 minus z1 whole raised to square. Midpoint formula, only this third coordinate is extra in case of three-dimensional geometry that you have to remember. So next important concept in the 3D is a plane. Instead of considering a straight line, you may consider a plane. Then the concept behind this plane in 3D we are going to study. So just we are defining what is meant by a plane. Plane is a surface such that a line segment joining any 2 points of it lies only on it. A straight line which is perpendicular to every line lying on a plane is called a normal to the plane. So normal also, the concept of normal is also used in case of plane while studying. So next, equation of a plane in the normal form. Equation of a plane in the normal form. Vector r dot n cap is equal to D. That is vector equation of the plane in the normal form is given by vector r dot n cap is equal to D, where n cap is a vector which is normal to the plane, unit vector. Next, Cartesian form of this is, or Cartesian form of the equation given by ax plus by plus z is equal to D, where ABC are the direction ratios of the plane, D is the distance of the plane from the origin. Another equation of the plane is Lx plus My plus Mz is equal to P, where L, M, N are direction cosines of the perpendicular from the origin, P is the distance of the plane from the origin. Next, if D is the distance from the origin and L, M, N are the direction cosines of the normal to the plane through the origin, then foot of the perpendicular is LD, MD, comma N. Next, equation of a plane perpendicular to a given vector and passing through a given point. Equation of a plane perpendicular to a given vector and passing through a given point. The vector from is that a plane passing through a point A with position vector A and perpendicular to the vector N is vector r minus vector A dot n cap is equal to 0. This is the vector form of the equation of the plane. Same thing if you are writing the Cartesian form, that is equation of a plane passing through the point x1, y1, z1 is given by a times of x minus x1 plus b times of y minus y1 plus c times of z minus z1 is equal to 0, where a, b and c are direction ratios of the normal to the plane. So next, equation of a plane passing through three non-collinear points. So that is in the vector form is, if vector A, vector B are and C are the position vector of three given points, then equation of a plane passing through the three non-collinear points is vector R minus vector A dot product of vector B minus vector A cross product of C minus of vector A is equal to 0. Same, if you are writing the Cartesian form, then you remember determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. If above points are collinear, then x1, y1, z1, x2, y2, z2, x3, y2, z3, this determinant value is equal to 0. So next, important point, equation of a plane in the intercept form. So here, in case of secondary PU studied, already studied, equation of a line in the intercept form, x by a y plus y by b is equal to 1. Just one more quantity or third quantity z by c is added, that is equation of a plane in the intercept form, where if a, b and c are the x-intercept, y-intercept and z-intercept respectively made by the plane on the coordinates, then equation of the plane is x divided by a plus y divided by b plus of z divided by c is equal to 1. So equation of a plane passing through the line of intersection of two given planes, vector form r dot n1 is equal to d1, r dot n2 is equal to d2, then equation of any plane passing through the point of intersection plane is vector r dot n vector n1. So actually it is like this, there plus of lambda times of n2 is equal to d1 plus lambda d. So now, where lambda is the constant and calculated from the given condition. So Cartesian form, if the equation of a plane a1x plus b1y plus c1z is equal to d and a2x plus b2y plus c2z is equal to d, then equation of any plane passing through the point of intersection of plane is a1x plus b1y plus c1z minus of d1 plus lambda times of a2 lambda times of a2 x plus b2y plus c2z minus d is equal to 0, where lambda is constant and calculated from the given condition. So next, coplanarity of two lines. Coplanarity of two lines. In the vector form, vector r is equal to vector a1, vector a2, vector a1 plus lambda d1, vector r is equal to a vector a2 plus mu b. coplanar, then vector a2 minus a1 dot product of b2 minus b1, vector b2 minus b1 is equal to 0. This it is possible to write these two equations in the Cartesian form. X minus Cartesian form equation of two straight lines are x minus x1 by 1 is equal to y minus y1 divided by b1 is equal to z minus z1 divided by c1, and x minus x2 by a2 is equal to y2 minus y2 divided by b2 is equal to z minus z2 divided by c2 are coplanar. Then this determinant x2 minus x1, a1, a2, y2 minus y1, b1, b2, z2 minus z1, c1, c2 is equal to 0. So this is how the coplanar condition. So next, angle between two planes, angle between the two lines. Similarly, angle between the two planes, we are going to calculate let theta be the angle between two planes. Then vector form if vector n1 and vector n2 are the normals to the plane, and theta be the angle between the planes. Then vector r dot vector n1 is equal to d1 first plane, second plane is vector r dot n2 is equal to d2. Then theta is the angle between the normals to the plane drawn from some common points. Cos theta is equal to modulus of vector n1 dot vector n2 divided by magnitude of n1 into magnitude of n2. The planes are perpendicular to each other. Dot product of this is equal to 0, and in parallel this is the condition. Cartesian form if the two planes a1x plus b1y plus c1z is equal to d1 a2x plus b2y plus c2z is equal to d2, then cos theta is equal to a1 into a2 plus b1 into b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square, which is an angular root. So next, planes are perpendicular to each other if a1 into a2 plus b1 b2 c1 c2 is equal to 0. Planes are parallel. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Next, one more point. Distance of a point from the plane. Vector form is distance of a point whose position vector a from the plane is vector r dot n cap is equal to d is d minus of vector a n cap. If the equation of the plane is in the form vector r dot n cap is equal to d, where n is normal to the plane, then perpendicular distance is d dot n cap minus of d whole divided by vector n. The length of the perpendicular from the origin to the plane vector r dot n cap d is given by d divided by vector n1, where because a is not equal to 0, in the Cartesian form the distance of the point x1 comma y1 z1 from the plane x plus by plus z is equal to d is given by distance d is equal to x1 plus by1 plus z1 minus b divided by square root of a square plus b square plus c square. Next, angle between a line and a plane. If the equation of a line vector r is equal to vector a plus lambda b, vector r is equal to a vector a plus lambda b, and so this is repeated. This is not necessary. Two lines are this is not necessary. And the equation of the plane vector r dot vector n is equal to then the angle is between the lines normal to the plane is given by what? So that is cos theta is equal to vector b dot vector n into magnitude of b into magnitude of n, and so the angle phi between the line and the plane is 90 degree minus theta. So sin of 90 minus theta is equal to theta, and sin phi is equal to magnitude of, that is modulus of vector b dot vector n divided by magnitude of b into magnitude of n. So Cartesian form, if a comma b comma c and or the directions of a line del x plus m y plus n is equal to 0, then the equation of the plane is given by sin theta is equal to this much. And next, lastly, if the line is parallel to the plane and if the line is perpendicular to the plane, then the conditions are there here. That is, if it is parallel a1 a2 plus b1 b2 c1 is equal to 0, if perpendicular a1 divided by a2 plus a1 divided by a2, this is the condition for parallel, and this is the condition for perpendicularity of the planes. So with this, today we are going to stop the discussion of three-dimensional geometry. Here the formulas plays a very important role. That's why you list out all these formula. So with this, today we are going to discuss the discussion. Thank you, one and all.